10.4 Hypothesis Test for Population Standard Deviation. Okay, so when we're talking about standard deviation, that means that we're going to end up going back to our chi-square distribution. So we need to remember that formula. So chi-squared is going to be our n minus 1 times s squared, all divided by sigma squared there for those, our standard deviation squared. So we always want to pay attention to those things. What is our variances and all of the information. So we'll be looking to pick those things out from our problems. Okay. Now we have all those same chi-square distribution characteristics that we talked about before with those pieces. So we'll kind of use that knowledge here, remembering those things. Okay, so all of this we've looked at previously on those slides. All right, so now we want to do our test hypothesis about our population standard deviation. Okay, so first we need to look at simple random sampling. It's normally distributed. And then we have our sigmas there. So anytime we're doing this, we are talking about standard deviation and variance. And so we need to pay attention to sigma. We still have our two-tailed, our left-tailed, and our right-tailed, just like we have in our other sections when we're looking at our pieces here. Okay. So the first thing is we need to compute our test statistic and see what we're up against here. And then we're going to compare that to our critical value for those things, and then paying attention, is it left-tailed, right-tailed, or two-tailed, to know what's going on there. Okay, so again, as before, two-tailed, it has to be in between those values. Then for left-tailed, our test statistic has to be less than the critical value, and right-tailed has to be greater than. Okay. All right, so, and then we can also look at our p-value. Now, again, they're going to do some different things, but we're going to let that calculator do those pieces, okay? All right, and so again, all of these things here, just kind of a repeat on those different pieces, okay? So again, we're looking to tell if we're going to reject or do not reject the null hypothesis for those, okay? All right, so if we go back to our M&Ms and Mars control quality engineer here, they looked at it and said the mean weight, the Snickers is 20.1 grams. Now suppose that we have a standard deviation of the weight of the candy was 0.75 grams before a machine recalibration with those. The engineer wants to know if the recalibration resulted in more consistent weights on those pieces. Conduct test at a 0.05 significance level for those. All right, and so they got this data here and wanted to be able to see what's happening on those things, okay? All right, and so we have our normal probability here, and we're going to look and say it looks pretty normally distributed. And so we need evidence to say that our standard deviation is less than 0.75 grams. And so that's telling me whether I need to recalibrate or not on those pieces. Okay, and so we want to pay attention to those details there. So this is a left-tailed test on those, and we have a significance of 0.05 when we're looking at those. All right. Okay, so the test statistic here, we plug those things in. So we have our n is 11. So we go back and count how many that we had in our chart. We had 11 items there, so n minus 1. Our s squared was 0.6404. Now we can get that from taking our table, we put that into L1, and we go from there. Okay, so we can always go back and do that piece. We've been doing that all semester. So we're going to put that table into L1 and find out our S value there. And so that's going to give us 0.6404. And then our standard deviation for this problem is 0.75 for these. And so we want to compare it against that piece, okay? So we put that in our calculator and we get 7.291. Now you're gonna have to use that formula. That's just part of it. The calculator doesn't give us those pieces, okay? All right, now, what if we're looking at comparing that against a 0.05 level of significance? And so this here would mean that we're gonna do 1 minus the 0.05 So our chi-squared, so we would go to our chi-squared table and look this up, okay? And so we're going to be, again, using 10 degrees of freedom, because 11 minus 1, and then pick that up on our table there, and we would get 3.940 off of our chi table, okay? All right, now because our test statistic is greater than our critical value, we do not reject the null hypothesis, all right? Now, had it be, as we can see on our screen there in the blue area, then we would reject the null hypothesis. But because it's greater than that, we're going to not reject the null hypothesis, okay? Now, we can also do our p-value. Now, this shows by hand. I'm going to show us in just a moment how we're going to put that in the calculator. So let's just kind of go through these slides and then we'll do these pieces, okay? Now, by hand, they find that they have some other values here, but let's look. They did it through a technology. Now, they used a different program. They used StatCrunch. We're going to use the calculator, and we're going to see that we're going to match up with those pieces, okay? So let's turn our calculator on here with this. And so we need to go into vars here. So we're going to hit second and then the vars. Okay, so second vars. And we're going to go down to chi-squared CDF. Okay, chi-squared CDF. Okay, now, if you have a TI-83 calculator where it doesn't give us these pieces here to plug in, that's okay with those. What you're going to make sure is that you have 0, comma, your chi-squared statistic, which we've already calculated, and then your degrees of freedom. Okay, and that's what we're going to need. And you see, those are the things. Now, they have lower and upper, but we're going to use the same values here, okay? So our lower is 0, or our first one is always 0. Our next one is the chi-squared statistic. Now, we calculated that a moment ago on our chart here, right? That's the 7.291. And then our degrees of freedom, we talked about, was 10. Okay? And then we paste. Now, if you're using the older calculator, it should look like this at this point. We all are going to be at the same area at this point. Just the newer calculators kind of give you a breakdown to plug in where, so that you know what goes there. And we press enter. Okay? So let's get back to that slide there where we had the chart. Well, you'll see as well that they have the same value here for p-value on those, and so we know that we are on the right track on those pieces. Okay, so we're able to calculate that directly from the calculator for the p-value only. Okay, for the p-value only. Okay, now since our 0.30 there that we calculated for a p-value is greater than the 0.05 significance value that alpha was, then we do not reject the null hypothesis. Okay, and so it still does the same pieces as we've done before. Okay, so there's not enough evidence to conclude that it's less than 0.75. Right? Now, the other things is here, just kind of wrapping up, what do I use where? Now, remember that if we're talking about proportion and using proportion, we're going to use the z-tables and the things that we talked about there. If it says mean, you're going to use your t-tables and the items there. And then for standard deviation or variance, you're going to use the chi-table for those pieces. Okay? All right, so those are the things that we need here for 10.4.